What the heck is a vector database? If you want to truly understand how AI applications like ChatGPT with memory, semantic search engines, and RAG systems actually work under the hood, this video is going to be one of the most important ones that you watch this year. Everyone is talking about building AI agents. Everyone is talking about RAG. But almost nobody takes out the time to explain the actual infrastructure that makes all of this possible. And that infrastructure is a vector database. I know what some of you might be thinking. Ash, databases, that sounds like a boring backend stuff. I get it. But trust me on this. Once you understand what a vector database actually does and why it exists, everything that you've been learning about AI is going to click into one place. So let's get into it. If you're new to my channel, hi there, I'm Aishwarya Srinivasan. I also go by Ash. I have over 10 years of experience in machine learning and AI, and I've worked at companies like Microsoft, Google, and IBM. And I've co-founded the Gen Academy, where we teach people how to actually build with AI. Everything I share here comes from real-world experience, not just theory. So let's start with the problem, because that's always the best place to start. Imagine that you're building an AI assistant for a company. The company has thousands of internal documents, whether it's HR policies, product manuals, or legal contracts. Your AI assistant needs to answer employee questions using that information. So the obvious idea is, let's dump all of these documents into a regular database and search through them. Here is why it breaks down immediately. A traditional database, whether it's MySQL or Postgres, it's designed for exact or partial text matching. Find me all the documents where the word vacation appears. That works fine for exact queries. But what happens when somebody asks things like, how many days off do I get per year? The word vacation might not even appear in that question. A traditional database has no idea those two things are related. Now, this is a core limitation that vector databases were built to solve. They are designed not for exact matching, but for meaning-based matching. And that distinction is everything. Now, before we talk about vector databases, we need to talk about vectors. And I promise it is not a math lecture. So think about how your brain understands meaning. When you hear the word king, you don't just store the letters K-I-N-G. You store a whole web of association. It's things like royalty, power, leadership, crown. Your brain has a rich, multi-dimensional understanding of what that word means in relation to everything else that you know. Now, machine learning models do something very similar. What they do is they convert words, sentences, images, basically any kind of data into a list of numbers. Now, that list of numbers is called a vector or an embedding. And here is the beautiful part. These numbers are not just random. They are positioned in mathematical space in a way that actually captures meaning. Words with similar meanings end up in similar numbers, which means they end up close to each other in that vector space. Here's the classic example that blows people's mind every time. If you take the vector for the word king, subtract the vector for man, and add the vector for women, you end up extremely close to the vector for queen. So the model has learned that royalty and gender are real and they are manipulatable dimensions of meaning. Now that's not magic, that's a well-trained embedding model doing its job. So when you convert your company's thousands of documents into vectors, you've translated all of that text into a mathematical language that captures meaning and not just keywords. Now, when a user asks a question, say something like, how many days off do I get this year? That question also gets converted into a vector, and the database finds the documents whose vectors are closest to it in meaning, even if they don't share a single word with the actual original question. That is what a vector database is built to do. And it does it fast even across millions of documents. Now, let me show you where this shows up in real world, because this is where this gets exciting. The most important use case right now in AI is RAG, which stands for Retrieval Augmented Generation. And I have an analogy that I always use for this. Think about a closed book exam. You can only answer questions based on what you have memorized. If you did not study something, you're just stuck. That is basically a large language model without RAG. It can only answer based on what it learned during training. Ask it something that happened after its training cutoff or something very specific to your company, and it's either going to hallucinate or just going to say, I don't know. Now imagine an open book exam where you have a textbook right in front of you. You get the question, you flip to the relevant chapter, read the relevant section, and then you write your answer using both your reasoning ability and the actual information from that book. Now that is RAG. The LLM is the student with great reasoning ability, and the vector database is the textbook. Now, if you want to go deeper into RAG, I've actually recorded a detailed video about understanding RAG. I'll link that in the description below so you can go check that out. Now, coming back to vector databases. Here is how it works in practice. You take all your documents and convert them into vectors using an embedding model. You store those vectors in a vector database. So when a user submits a query, you convert that query into a vector, search the database for the most semantically similar documents, retrieve the top results, pass those results along with the original query to the LLM, and then the LLM generates a grounded and accurate response instead of guessing. Now, this is why RAG is such a big deal. It solves the hallucination problem for domain-specific knowledge. And vector databases is the heart of the retrieval step. One thing I want to flag, because this is a mistake that I see constantly. How you chunk your documents before converting them into embedding is just as important as the database that you choose. If your chunks are too large, you lose precision. If they are too small, you lose context. A solid starting point is about 300 to 500 tokens per chunk, with about 50 to 100 tokens of overlap at the boundaries. And use a semantic chunker if your framework supports it, not just a fixed size character splitter. The difference in retrieval quality is real. Okay, now let's get practical, because I know some of you are ready to build. There are a lot of options out there, so let me be direct about where you should start. If you're getting started and want to experiment locally, I would say go with ChromaDB. It's incredibly easy to set up and works great with LangChain and Llama Index, and you can have a working RAG prototype on your laptop in under an hour. Now that is your entry point. If you want performance and want to self-host, look at Qdrant. It is open source, written in Rust, so it's extremely fast and memory efficient, and their documentation is amazing. You can run it locally with Docker in 5 minutes. Now, if you're building a production application and don't want to manage the infrastructure, Pinecone is the most popular fully managed option right now. It scales automatically, integrates well with most AI frameworks, and the free tier is generous enough to prototype before you commit. And then there's Weaviate, which is worth knowing about because it supports hybrid search, meaning that you can combine vector similarity search with traditional keyword search in the same query. That's powerful for production use cases where you want the best of both approaches. Now, I want to spend just a minute here because vector databases are not just for RAG, and I don't want you to be leaving with that impression. Spotify uses vector similarity to recommend songs that you've never heard but you'll probably love, because your listening history gets converted into a vector and matched against a catalog of song vectors. Netflix also does the same for content recommendation. Also, Pinterest lets you take a picture of a room that you love and find visually similar pins, because that image gets converted into a vector by a vision model. Not just that, anomaly detection in cybersecurity works the same way. Normal network traffic clusters together in a vector space, and behavior that's far away from that cluster is your alert. So the mental model is always the same. Convert your data into a rich numerical representation, store it in a way that makes similarity search fast, and use that for matching, recommendation, or retrieval. Once you internalize that, you'll start seeing vector database use case everywhere. Okay. To wrap all of this up, everything that I mentioned is linked in the description below, including the docs for ChromaDB, Qdrant, and Pinecone. And I've also added some hands-on RAG tutorials that will help you get started. Also, do remember to check out my RAG explained video. And if you want to go much deeper on building real agentic AI end-to-end, come and check out the Gen Academy's upcoming bootcamp. My co-founder Arvind and I have built a deep dive mastering agentic AI bootcamp that covers agent architecture, orchestration, RAG, tool usage, evaluation, and deployment, all with hands-on projects. It is not just for AI builders, it is also catering to adjacent AI roles like AI PMs, tech leaders, program managers, GTM leads, marketing leads, or product marketing managers. The goal is to help you be very, very technical and at the same time make you AI native so that you can actually build AI agents from scratch. Now, for the AI builders, for example, software engineers and AI engineers or solutions architects, we have assignments which are focusing more on code. And for the non-coding professionals, we have low-code and no-code projects. So everyone at the end of the bootcamp is going to be building a lot of projects. Plus, we have collaborated with companies like NVIDIA, Nebius, Llama Index, Ollama, Whisperflow, AG2, and many more to get you free credits and free access to their tools. Plus, we are inviting some of their top AI engineers and AI leaders to come and give you guest lectures. It's going to be a super packed agentic AI bootcamp, so definitely go check it out. Hope this was helpful. I'll see you in the next one.